React developers spend years learning about hooks. They learn how to handle state correctly, they learn how to write clean reusable components, but there's one command almost everyone runs without ever looking at what it's actually doing, and it's their build command. Most developers treat it like a black box. All they see is that their build goes through without any errors, a build folder is successfully created, and then they just simply ship their code. Today, I want to shift that perspective because it's important to optimize your build for better performance. Otherwise, it's you who will have to explain 6 months down the line why your app takes 10 seconds to load on a user system. So in this video, you will learn how you can optimize your React apps for better performance like a senior React engineer would. So let's get straight into the details. For the purpose of this video, I've created this fairly normal looking React dashboard here. It's nothing exotic, and it uses React Router, a chart library to render graphs, a few icons, and a custom font like most React applications have. This app only has two routes, the main root route which navigates to the dashboard, which you see on screen here, and then there's the product details route which opens when you click on a given product. Now let's run a production build on this application and see what we're actually working with. So let's go ahead and open a new terminal and we'll type in the command npm run build to generate our build artifacts. So right away you can see that there is this one single file which is almost 1.5 MB in size, and it's this file which has all of our JavaScript code needed to run this application. But it's way too much for such a small application to have such a huge build size. And since we're using Vite as the bundler here, you can see that Vite itself is throwing a warning about it in the logs below. It says that some chunks are larger than 500 KB even after minification, and it's talking about this main file here which it has also highlighted in the yellow color. So we don't even need a separate tool to tell us something's off here. Even if you're using Webpack or Rollup, you will see a similar error. By the end of this video, we'll take the same app, same features, nothing removed, and get it down to this version of the build instead. So let's go step by step and see exactly where that size is coming from and what we can do to optimize our React build. Most of the optimizations that we will discuss can be applied to all React apps no matter which build tool you are using. Since Vite is the most commonly used tool for modern React apps, I've built this video around it. So let me go ahead and expand the terminal and we'll scroll a little bit up. Before we even touch any of the JavaScript code, by just looking at the build logs, we can see one problem right away. There are 12 font files, which includes 6 character subsets for 2 different font weights. But in our application, we are not even using most of them. We just need the single Latin subset. So let's go ahead and check where we are importing this font in our code. Here is this one line. And most of the developers do not realize that importing your fonts like this pulls in every subset because that's simply how the package is structured under the hood. I didn't ask for the Vietnamese or the Greek subset, but I got them anyway for free whether I wanted them or not in our final build. So this fix is almost insultingly simple once you know it exists. Instead of importing the whole library, we will just import the subset we actually need, and the rest will be ignored by a build tool by default. So let's go ahead and make this little change and rerun our build command to see if the other subsets are still getting included. So instead of importing the entire module, we will just import the specific subset file we need. So let's go ahead and run our build command again. And you will notice right away that the other subsets are not getting imported. Let's go ahead and also confirm this on the browser. So we will open the network tab and refresh our app. And if we filter by the font source files, you will see that only the Latin subsets are getting downloaded. So this was the easiest win for the whole video, and it's also the one nobody thinks to check while they're importing font modules. Now let's move on to reducing the build size of a main JavaScript asset. And to check what the final build is composed of, I will use the Rollup plugin visualizer to visualize the tree map of everything that's in our actual JavaScript output, sized by how much space it takes. So if I go to the Vite config, you will see that I have the plugin for the visualizer already configured in, and it's created this stats.html under our distribution folder. So I'll go ahead and open this particular file on the browser, and as you can see, apart from React DOM, there is this enormous block dwarfing everything else on the page. and that's the eCharts library. It's the library we are using to render bar charts for our application, but this library has dozens of other chart types available while we only need the one chart that we are using on our page. And we have probably imported the entire charting engine just for that one use case. Now to fix this, let's check the eCharts documentation, and if we scroll a little down, we will see that eCharts library itself supports an interface with which we can reduce the bundle size of the library. So we'll take the example they have provided as the reference here, where they are using the use method to register the components that we will actually be using and update the imports in our stats chart component. So as per the documentation, we will just import the core components from the eChart library. So we will update this particular import statement by adding /core. Then we will include the individual import statements for the components that we are actually using from this library. And then we'll finally add the interface using which we can reduce our bundle size. So let's save all of our changes and run the build command again. And as we can see, the build size of the main JavaScript file has reduced dramatically. It went down to 860 KB from 1.5 MB. And what we did here is defined as tree shaking. It is an optimization technique used in JavaScript to remove dead or unused code. Modern day bundlers like Webpack and Vite do this automatically for most of your imports. If there is an unused module in your app, your final build will not even contain it. And in our case, we had to do this explicitly using updated import statements, as it's a known problem with this library, and the maintainers were kind enough to add this interface to reduce the bundle size. Many other libraries like Material UI also achieve this by simply splitting their products into multiple packages. For example, Material UI's icons and data grid libraries are different from their core library. So far, what we did was just updating our import statements to optimize our application. Now let's move on to further optimize this project by using an advanced React concept known as code splitting or lazy loading. As we know, in our main component app.jsx, we are defining the two routes we are using inside our application: the root route for dashboard and the product route for the product details component. Now the JavaScript for both of these components is included within our main index build file. So as soon as the user opens the landing page, which is the dashboard, the JavaScript for both of these components is loaded simultaneously. But the thing is, we do not even need the JavaScript for the details component to render our dashboard. So we should not be fetching them together in the first place. And that's what we can achieve through code splitting. We will divide the main JavaScript build into two separate slices, and when we visit the dashboard, we will get the dashboard slice only. And if we never click into a product, the details page code will never even get downloaded. So for that, let's scroll onto the top of the file. We will import lazy and suspense from the React library, and then instead of directly importing our components, we will use the lazy function to lazy load them. So we updated the import for our dashboard component. We'll also do the same for our product details component. And finally, for all of this to get applied, we will wrap our routes inside the suspense component like this. Now let's go ahead and run our build again. You will see that the product details assets have been separated out from the dashboard assets. And now if we run the command npm run preview and launch the application in production like mode, you will see that when we land on the application, the JavaScript for product details was not even downloaded. And it's only when we click on a product, the necessary JavaScript for that particular component is loaded. And this is basically what code splitting achieves. And now for the final optimization step for this video, we will apply vendor chunking. Vendor chunking is a build optimization technique that separates third-party node module libraries from your main application source code into an independent bundle file. And this does not reduce the bundle size, but since we will be separating the third-party vendor JavaScript, it will help in caching those build files in the browser. So once a user downloads these vendor files, they will not have to download them again even if we change our React code, as the static vendor code is now separate from our main React code, which has the evolving business logic. And to do that, let's go ahead and update our Vite config, where we will now add a build option, and within this we will define our vendor chunks. So here we have the three main vendor chunks which are stored under this chunk map constant. The first one is having all of the React related code. The second one is having all of the JavaScript for eCharts, and the third one is having other utils like Lodash and Moment. Now if you want to use this same optimization technique, I will be pushing all of this code to GitHub. and you can directly reference this particular configuration from there. So now once we have defined our vendor chunks, let's go ahead and run our build command again. And as you can see, we have 3 separate vendor chunks now. And you will notice that even the size of the index and dashboard build components have drastically reduced. And this shows that most of the size within these build files was due to the vendor libraries. And since now we have separated them out, the build size of the files having our actual business logic has further reduced. So now if we go ahead and run npm run preview again to run a production like server, and go to the browser and reload our application, you will see that along with the dashboard and index JavaScript, you have all of these other vendor JavaScript files getting downloaded. Now, the best part about separating out these vendor files is that unless and until you go ahead and update the vendor packages in package.json, these build files will not change, and hence they will stay cached in your user's browser. And that's a very big advantage for us, because the only JavaScript which was slowing down our app were these vendor files. And now since they will be cached, we do not have to worry about them getting downloaded again and again whenever we make changes to our code, because they will simply not change. And that was it. This is how we optimize this React build. We did not remove any features or rewrite the application. We simply understood what was actually being shipped to the browser and optimized it step by step. And that's the real takeaway from this video. Modern build tools are themselves incredibly powerful, but treating them like a black box means you'll miss opportunities to improve your application's performance. The better you understand what's happening under the hood, the better engineer you'll become. If you enjoyed this deep dive, consider subscribing to the channel, as I will create more such videos on advanced engineering topics in the future. So thanks for watching, and I'll see you guys in the next one.